you are advised to bring your questions as usual. Endeavor to watch our last live stream. So, as usual, I'll be continuing with the questions where we stopped in the yesterday live stream. The questions we have already made. So, I will push to the file, but before then, okay, Francis, you're welcome. You're welcome to today's live stream. So, how we're going to do it as usual, we continue from where we stopped yesterday. These are the questions as you bring your own questions alongside. So, I think we stopped at question number 6, which says that, okay, Former, you are there. Thank you. You're welcome once again. So, the question number 6, we have answered it that it is actually that barium oxide is more metallic. So number 7 here says, which of the following, I guess we can see those online, I hope you can see these questions clear. I guess these questions are clear on the screen. Indicate if they are clear. I believe so. If they are clear, okay. Okay, thank you, Jude. Then we say that number 7 says, which of the following gases is suitable? Thank you, Olatoye. Which of the following gases is suitable for cancer treatment? So, you know, these gases here are all noble gases, starting from neon to radon in the correct order that they are arranged. So, from neon to radon are all noble gases, but the radioactive one is the radon. So the answer to this question is D. So radon, because it is radioactive, therefore it can be used to treat what? Cancer. You're welcome. Confidence, Francis. Thank you. So question number 8 says, which of the following informations is not provided by Lewis electron dot structure? Which of the following informations is not provided by Lewis electron dot structure? Lewis electron dot structure is what we draw every day, but we don't know. Let's assume you want to draw methane, you draw something like this. This should be the Lewis structure, but this one has no unpaired electron. There is no lone pair, therefore we don't have it. But if you take a look at ammonia over here, ammonia have one lone pair. You see, electron dot. So this is what we call Lewis structure. It shows the number of bond pairs and lone pairs. So checking this thing here shows that ammonia has 1, 2, 3. So bond pairs are represented with dash, then lone pairs are represented with dots. These two dots shows one lone pair. Therefore, it's only, they said which one is not. They are asking us the one that is not provided. The number of inner shell electrons, yes, is not provided. The number of bond pairs, yes, like I told you, this ammonia has 3 bond pairs. The number of lone pairs, yes, ammonia has 1 lone pair. Then the number of electrons in the outermost shell, of course, it shows the number of electrons. So the number of inner shells is not provided by Lewis electron dot structure. Is a conventional way of representing compounds, mostly covalent compounds or coordinate covalent, by using dash or full line for the so-called bond pair and then dots for lone pair. Okay, so we move on. The correct electronic configuration of Cr, that's chromium, this is where we should know little deviations. Remember, you're advised to come with your questions. I am answering these questions. These are actually my questions, which are prepared to expose some of your weaknesses and help you to know more, to score high in this forthcoming examination. Now, this chromium is a transition metal, and it has one unique way. There is one unique way on how we write the electronic configuration of transition metals. So let's see the notes. Okay, let's clean out this. Remember, you are on with SirMajesty Easy World Science channel, the Easy World of Science. If you have not subscribed to this channel, endeavor to do so. Cannot do without you. Okay, you're welcome, my dear. You're welcome. Samuel, Michael, welcome. Aliu, you're welcome. Thank you, guys. So, what we are saying is transition metals, you know, they are the D block elements. The D block elements are what we call the transition metals. And then we define them as elements with partially filled d orbital, elements with partially filled d orbitals, elements with partially filled d orbitals. That is what we call transition metals. Then you have the first series, the second series, where the first one starts from scandium, titanium, vanadium, chromium, manganese, iron, cobalt, then nickel, copper, zinc. This is the first series, of course, starting from number 21 to 30, where here is number 21, 22. I'm talking about the first transition series. First transition series start from 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So for you to get this off head, you can use the acronym serious tetanus virus causes malaria in cold night condition zone. Yes, this is an acronym that will help you remember them. You can say serious tetanus virus, virus for vanadium, causes for chromium, malaria for manganese, in for iron, cold for cobalt, night for nickel, then condition for copper. So let me take it further away where I can feel it well. So you can use this acronym: serious tetanus virus causes malaria in cold night condition zones. That is to start from the scandium to the zinc. That's from 21. You know, students often memorize the first 20 elements. Now I'm helping you to know the first 30. You can say serious tetanus, like a statement: serious tetanus virus causes malaria in cold night condition zone. Causes malaria in for iron, Fe, that's iron, cold for cobalt, night, then condition, and then zone. So this acronym will serve you well in understanding the first transition series. So what matters here is that they have d electrons. So we are going to teach you how to write the number of d electrons that they have, which is what that question said. How to write the configuration for the whole d, that is for the whole series. There is what I said, there is no 9, no 4, meaning we don't have anything like d9 and d4. So we can only have here elements in the first series starts from, this is 3d1, then this should be 3d2, this should be 3d3. Then chromium, instead of saying 3d4, no 9, no 4, you can say no night, no 4, meaning no 9, no 4. So instead of saying 3D4, it becomes 3D5. This is 3D5, okay? So instead of having 1, 2, 3, 4, 5, what we have is 1, 2, 3, 5, 5. 1, 2, 3, 5, 5, 6, 7, 8, 10, 10. Correct. So this will be 3D6, 3D7, 3D8. Instead of 3D9, we have 3D10 and then 3D10 for the first transition series. So in writing the electronic configuration of the transition metals, there is no 3D4 and no 3D9 for neutral atoms, but ions can have D9 or D4 for ions like copper 2 ion. But when they say neutral atoms, so the question asked us what's the correct electronic configuration. We go by normal thing is, remember that this is 24, so what it should be is 1s2, 2s2, 2p6, 3s2, 3p6, then as usual 4s2. You have exhausted for calcium, and then this is 20, and normally you now say 3d4. This is not what is supposed to be. This is wrong because there is no d4 and there is no d9. So what should be the correct configuration? So the correct configuration will be, what we are going to do here is, in this order there is a special stability because chromium falls under d5. So what we're supposed to write is 3p6, 3d5, and 4s1 instead of 4s2. So if you calculate, you have 2 plus 2, 4, plus 6, 10, plus 2, 12, plus 6, 18, plus 5, 23, plus 1, 24. So this is the correct electronic configuration of chromium. Then sometimes you might have a charge. If there is a charge here, charge of +2, how do you then write this? This charge shows that this particular charge here is telling you that you are going to remove 2 electrons from that 2 electrons has been lost. Therefore, the total electron remaining is no more 24, rather it is now 24 minus 2, like I taught you in the last live stream. So how many electrons are remaining? 24 minus 2. So we are distributing 22. So in this case, this 4s will go first and another one here will go. Therefore, if you are writing chromium 2 ion, of which I know we don't have, I think what we have is chromium 3, is allowed to write D4 because it has lost one of the electron here and lose one again. This is for charged ion, but for neutral atoms you don't put D4. So what if I put 3 here? It becomes 24 minus 3, so the total electron remaining should now be 21. So the correct configuration is supposed to be, this one will go first, then 3 will leave here, so it will end in 3d2. That is it. Every other thing is constant here. See what I mean? This one is there, 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 there. So that is it. What I'm teaching you is also applicable to other lower members in the series, like the first, second, and third transition series is also applicable. Like the next one here should be probably yttrium, lanthanum, then zirconium, and so on and so forth, hafnium. So let me go to what we want. Niobium, technetium or tantalum, then molybdenum. Here is tungsten. So if you take about chromium, molybdenum, and tungsten, they all end in D5 and not D4. So just like chromium, the same thing is applicable. Under copper, we have copper, silver, and gold, if I'm correct. Yes. So these ones also end in D10, ND10. That's how they all end. So that's just by the way. You now go back as I wait for your question. So the correct electronic configuration, option A is to tempt you, because if you count it, it is 20. But since we don't have D4, it is incorrect. Option B is still incorrect. It's the same thing as option A, only that the position of 4S and 3D has been changed. Then option C had it correct. Option D is incorrect. So the answer is C. So question 10 says, you're welcome, my dear. Okafor, wisdom. Well done, well done. Remember, your questions are welcome. Then number 10 says, the following are pairs of elements that show diagonal relationship in the periodic table, except those elements that show diagonal relationship in the periodic table. What do we mean by diagonal relationship? If you come to the periodic table, some elements are connected diagonally, and we say they exhibit some features. For example, let's take a look at group 1 and group 2. It will help us establish diagonal relationship. So here is group 1, here is group 2 elements. So group 1 element starts from hydrogen is not actually a metal, but lithium. It starts with lithium, sodium, potassium, rubidium, then cesium and francium. Then group 2 starts with beryllium, magnesium, calcium, strontium, barium, and radium. So this is the group 2 and group 1 elements. See what we mean by diagonal relationship. If you move from lithium, okay, you said, I will come to your question. It has disappeared, but you see it on the screen, of course. So here, watch this. This is diagonal relationship. Maybe I go to the notes here, but that will make me repeat. So we have lithium, sodium, potassium, rubidium, cesium, francium. Then here is beryllium, magnesium, calcium, strontium, barium, and radium. So this is group 1. And here is group 2. You can use the acronym, let St. Paul remember Christians forever. Let St. Paul remember Christians forever. Be majestic, can skills be real? So if you use this, you remember the group 1 and group 2 elements. Now see what we mean by diagonal relationship. Sodium and calcium are diagonally connected. On the diagonal, lithium and magnesium are diagonal. So but the ones that show diagonal relationship in the periodic table are notably lithium and then magnesium. Then another one is beryllium and aluminium. So beryllium and aluminium show. Then we have silicon, and we will see it more in the periodic table. Let me try lifting some of the periodic table. Besides, we are still on with SirMajesty Easy World. Okay, this is the Majestic periodic table I constructed. It's also available for sale. You can place order. This table is more informative than any other table you can see. You see, it has the electronic configuration of all the tables. Okay, I've gotten your question, my dear. Thank you. I'm coming to attend to that. So let me finish up with this particular question. So this particular table is designed by me, actually. It is more informative than any other table you can see in the market. This is the Majestic periodic table. It has a unique feature. It has the diagonal relationship is there. You see the shells, you see the methods. So there are many features present on this particular Majestic periodic table. So you are advised to place order for your own. Now see how I show elements that show diagonal relationship. You see the yellow arrow, boron and silicon show diagonal relationship. So let's go here and see another one. You see the key, they say pairs of elements that show diagonal relationship. We have seen boron and silicon. Now you see lithium and magnesium, like I told you. Then another one is beryllium and aluminium, but because they are very far apart, there is no way we can link them. So these three pairs are notably the elements that show diagonal relationship. That is on the diagonal. And remember, some people erroneously call this thing diagonal relationship. You see this dark thick line? No, this is what we call the staircase on the amphoteric line. So when you get the table, it will teach you more what this amphoteric line means. That's not diagonal relationship. So we have three pairs of elements that show diagonal relationship, which are boron and silicon, boron and silicon, lithium and magnesium, then beryllium and aluminium. So we go back to the question and then choose the correct answer. Okay, here is where we get that question. So the question number 10 says, which of the following pairs of elements are pairs of elements that show diagonal relationship in the periodic table, except. So the correct answer there, can you now answer? Good evening, you're welcome, my dear. So which one is the correct answer? From what I explained, suggest if you are alive. Number 10, what's the correct answer? I want to see your response. If you understand the explanation, okay. Maybe this is lagging, but I think the transmission is fast with real time. I've told you aluminum and germanium, no. So the answer is A, because option B, C, and D all show diagonal relationship. So that is it. Now let's go and check your questions and answer them in the order you sent them, of course. So what we're going to do now is you trace this here. It will definitely, okay, it's showing us here. So we enter the live. What we'll do now is you trace this here. Okay, here are your comments so far. Here are your comments. So let's I'm going to take a screenshot of it and then continue. Okay, so over here, besides, I think this needs to be saved. Then we leave here. Okay, we come back here. So this is it. The first question says, so the main product of electrophilic addition of HCl to 2-methyl propene is, in this case, you need to know what we call Markov-Nikov's rule. Markov-Nikov's rule should play a role here. So I hope you are seeing your questions. The Markov-Nikov's rule. I saw someone's question now, but you have to be patient. Then the other person says, an ion has a charge of +3. The nucleus of the ion has the mass of 120. The number of neutrons in the nucleus is 1.5 times that of the number of protons. How many electrons are there in the ion? Okay, we will reason that out. So now, in this question you asked me, product in the methylpropene, you are going to make do with Markov-Nikov's rule. So to answer that question clearly, so let's go and draw so that you get what I'm saying clearly. So based on Markov-Nikov's rule, I might lift your question from here. I think this is the question here. Yeah. Why is it double lifting? Is it the same thing? Yes. Okay. So we keep it aside as we solve. Then you say 2-methylpropene. So this is over here should be our 2-methylpropene. So let's check the hydrogens. This one is satisfied. Then hydrogen will be 2 here, and 2 here, and 2 here, then 3 here. That is it, plus HCl. The only thing there is that you should know about Markov-Nikov's rule. Markov-Nikov's. So the Markov-Nikov's rule applies when alkenes, mostly when alkenes reacts, undergoes addition reaction, that's addition reaction with the so-called hydrogen halides. Hydrogen halides. The hydrogen halides. So what do we mean by hydrogen halides? We all know what halides are. Halides means compounds of the so-called noble gases. So compound of the, not noble gases, sorry, the halogens, the halogens, please. So the halogens, the compounds of halogens is what we call, okay, let me shift this. So the halides, okay, it's better I remove it entirely. Like, you know, we have, in the halogens, we have fluorine, chlorine, bromine, iodine, astatine. So the AT, if you put hydrogen behind them, it becomes hydrogen halide. That's hydrogen fluoride, hydrogen chloride, hydrogen bromide, hydrogen iodide. So Markov-Nikov's rule applies when alkenes undergoes addition reaction with the hydrogen halides. It states that the carbon, in what I say, let the rich get richer. If you're over there, you repeat after me. Let the richer carbon get richer, and let the poorer carbon get poorer. But please don't behave like that in life, actually. But this Markov-Nikov's rule supports the idea that the rich will get richer and then the poor will get poorer. See what it implies here. I'm going to draw this structure in a bold way so that you understand that Markov-Nikov's rule. The Markov-Nikov's rule. I might not get the spelling well. Might not get it well. You say the volume of carbon dioxide. Okay. I'm coming straight to handle it, my dear. Now, in this case, the Markov-Nikov's rule says that the carbon with more hydrogen gets more of the hydrogen. Then carbon with less hydrogen gets the halogens. So over here, Then you say plus HCl. Watch this. There are two things that will be adding on to this. Remember, these two carbons are the carbon that will undergo addition reaction. Why? Because 1 and 2, that's these two carbons here now, this one and this one, are saturated. So the addition reaction will occur between the two carbons surrounding the double bond. So the hydrogen halide will add onto this carbon or onto this carbon. The question is, which among these two carbons will receive the hydrogen and which one will receive chlorine? See what I mean? Will I place chlorine here or will I place hydrogen here? Now, the rule, the Markovnikov's rule says that the carbon with more hydrogen will get the hydrogen. So the rich in hydrogen gets richer, and the ones that have less hydrogen will get the halogens. So the meaning is, check this carbon. How many hydrogens are there? 1 and 2. Check this carbon, 0. So there is no hydrogen at all. So this is 0 and this is 2. So the correct compound formed actually is the chlorine will come here and the hydrogen will come here. So the correct compound formed is Cl and H. We now clean off the double bond so that the compound is now 2-chloro-2-methyl. So the compound formed should be 2-chloro-2-methyl propane from the substitution, 2-chloro-2-methyl propane. That's the answer. So we go to the next person's question, which says an ion with before then, let me still check if one of the special people has actually made a comment. Okay, let's refresh this. The live chat, has it refreshed? I guess this wasn't the first one we got. No hash there. Okay. Saving automatically. Okay. Now, sorry. Let me quickly lift the next question. I guess that's the next question. An ion has a charge of +3. The ion has charge of +3. The nucleus of the ion has the mass of 120. Fine. That is, the mass of 120 means mass of protons and neutrons. Then the number of neutrons in the nucleus is 1.5 times that of the number of protons. So 1.5 times the number of protons, which means if protons is actually 1, it means the neutrons is actually 1.5. So in other way around, it is just 5 times more, that's 0.5 times more protons. So it's going to have exactly, okay, no problem, we'll do the mathematics. How many electrons are there in the ion? First of all, we have to note the number of protons, and from the number of protons we will understand that. So 1.5 means if you take about 1.5, that is 1.50 is okay, let's reason it out. That's it's not a hard question. This is just mathematics. They said the proton is 1.5 times more in number. So let's assume that the total number, okay, yes. So, okay, the total mass is 1.5. So if we divide 1:1.5, that should be it. Yes, 1 is to 1.5 between 120, we can get that of this should be the proton and this should be the neutron, because since it's 1.5 times, it shows that how many times is 1.5 more than 1? It's just 1.5 times, because if you divide this by 1, it gives you the same thing. So in that case, you sum the ratio, the total ratio is 2.5. So if you want to get the number of proton, you say 1 over 2.5 times 120 over 1. So going to that means the number of protons is 120 over 2.5, and then dividing 120 by 2 will give you 60. Then half of 60, that should be probably, let's check if the equation is correct. 120 divided by 2.5 is 48. So the number of protons such atom has 48 protons. So now, to check if our answer is correct, what is the half of 48? Half of 48 is 24, right? Yes. So if you say 48 plus 48 plus 24, if it did not give us 120, it means our solving is faulty. So let's check if it is correct. So if you put 4 here and 2 here, it's not giving us. This is going to be 12. It will 12. Then this is 72. Then 8 and 4. This is 0. You carry 1. Correct. So the number of protons is 48. Therefore, and it has a charge of +3, right? So we now represent the element in this way. 48 down, charge +3. Up here is 128. So for you to know the number of electrons, like I've been doing in this video, you just minus, do negative counting. If you see plus, you minus. So the total electron, it initially had 48 electrons, but it has lost 3 electrons, such that what is remaining now is 48 minus 3, which is 45 electrons. So the answer to your question is 45 electrons. Thank you, guys. Okay, let's go and meet the next person's question. Okay, so the electrons present there is nothing but 45 electrons. This is a reasoning question. It's not all that too hard. Then, okay, let's check the other questions that follows. Okay, you said what volume of carbon 4 oxide is produced? What volume of carbon 4 oxide is produced at STP when 2.5 grams of calcium trioxocarbonate 4 react with excess dilute hydrochloric acid? Okay, it is a simple something. You say what volume. So your job is just to know, write the equation and know this. We are working with calcium trioxocarbonate 4 and dilute hydrochloric acid, and the mass of the limestone given was so it's a simple something. You do your equation, but before then we have to write the equation. The reactants are what? Calcium trioxocarbonate 4 and then dilute hydrochloric acid. So we go here, clean off our board. Okay, maybe let's maybe we'll try here just to, then we will be needing white instead. So we have HCl plus calcium trioxocarbonate 4. We wrote this equation yesterday. It will give you calcium chloride plus H2O plus CO2. Remember, you're on with SirMajesty Zero Science channel. I cannot do without you. So your academic success is one of my topmost priority. Now, I am telling you, obviously, that this should be your last JAMB, and by so, I am in advance telling you happy matriculations. And don't forget to invite me when it happens, of course, because no more uni home these days. And don't forget that I also handle biology and chemistry related courses in your university: biochemistry, human anatomy. You have the metabolic pathways. Mention them as you talk about the organic chemistry, those early chemistries. You're welcome. Definitely it will happen. Francis, thank you for saying amen to the prayer. Okay, so let's go back and then continue. But please, you are on with SirMajesty Easy World. You are live with me. This is the second day of this live stream, the second and also the last day of the live stream for this forthcoming JAMB. What you need to do for SirMajesty Easy World is to subscribe and also share this video, spread the light. When you see the light, it is either you are the candle producing the light or you are the mirror that is reflecting it. I cannot do without you. So let's go back and finish up the question we are solving. So check this. We have balancing the equation. There must be 2 here. Yes, of course, to balance the chlorine, and that 2 balances everything. We have to be careful, because if we don't balance this equation very well, we will fail the question. So check well if it is balanced. Oxygen is 3, oxygen is 3 here, carbon is 1, carbon is 1, calcium 1, calcium 2, chlorine 2, calcium 1, calcium 1, chlorine is 2 here, chlorine is also 2 here. So the equation is smiling. So you bring down the mole ratios, which is 2:1, 1:1, 1:1. So we have gotten the mole ratio. Now, how you solve this question? You check the related species. The related species I mean here is the given and calculated for. They gave us this. If I can remember, they said 2.5 grams. And they are asking us to calculate the volume of carbon 4 oxide evolved at what? STP. So at STP, which means we are going to be taking these 2 and these 2, and it will land us to having that 1 mole, because there is 1 here after balancing. 1 mole of CaCO3 will give us 1 mole of CO2. The next thing you do, you find the units that these features bear, meaning in the one they gave us about this calcium triazocarbonate 4, is it in mole, mass, or volume? If I can recall, that was in mass, that is 2.5 grams. Then they are asking for this in volume and not mole and not mass. Therefore, I'm going to convert these moles to rhyme with the units they gave us in the question, which means I'm going to convert 1 mole of CaCO3 to mass, because the question had this CaCO3, CaCO3, like some students say, it had it in grams. Then this CO2 was not, they are not asking us to find the mole, so I will convert the mole to suit the volume. That means at STP, 1 mole of any gas occupies 22.4. So now we have that 1 mole of any gas is 22.4 dm³ at STP. Then here I'm going to convert this thing to mass. What is the molar mass of calcium triazocarbonate 4? The molar mass is 100, to save time here. Now, instead of writing 1 mole of CaCO3 gives 1 mole of CO2, I will now write 100 grams will give me 22.4. Then I will write X under the calculated for. What are they calculating? It is CO2 that they are calculating. I'll write X there, and now write the given mass, which is 2.5, and the job is half done. It's almost done. So what we are going to do now is you cross multiply. But if you meet with this in exam, you can equally do the predictions. Remember that 100 divided by 4 is 25, and 25 divided by 10 is 2.5. So you divide this thing by 4, although not everybody will get it correct. So let's use cross multiply. If you just divide this by 4 and also divide by 10, divide by 4, then subsequently by 10, you get the same answer. Okay, but cross multiply shows that this is 100x equal to 2.5 times 22.4. So we have that 22.4 times 2 is 44.8. Yes, then 44.8 times half of 22.4, that's time plus 11. So you can do this without your calculator. 44.8, half of 22.4 is, okay, if I have time I'll still attend to your question somewhere. Now 44.8, because the time is ending for this live stream. 44.8 plus half of 22.4, which is 11.2. So we go by, this is already 0, you carry 1, 4, this is 6, because 4 plus 1 is 5, plus the 1 you carried, which is giving you 6. There will be a point here. Then that's 56 on the dot. So 56, 100x is equal to 56, such that x is equal to 56 divided by, let me bring this up again, divide by 100. So 56 divided by 100 is easy to find. If you see anything dividing by 100, you move the points backward depending on the number of 0. You don't need calculator, so I'm trying to get the answer to this without calculator, and I think I'm heading towards there. So 56 divided by 100, how many zeros are here? 2 zeros. You just bring this 56, this is 56, this is where after every number have a point. This is 56.0. So you move this point 2 places behind, 1, 2, put it there, and if you put it there, it becomes 0.56. That's the answer, 0.56 dm³. That's the gas, the volume of gas liberated. Understood? Okay, remember you can also join further teachings for your private class, for schools and individuals. You contact me with +234 65166 217 on WhatsApp, or you can place a call, but be civilized as you do so. Remember, your success is my topmost priority. I cannot do without you. I thank you guys for coming online to watch and then have the final live chat for your final exam. My wish already for you is 90 and above. So your minimum mark should be 90, and when I say plus 90, it can now be 5 plus 90, which is 95. Any other thing you get should be extra. Then don't forget to come and testify in our channel so that we can collectively celebrate your success together. When you are going, we were away. Now you have succeeded, we will also be away. Understood? Okay. Okay, let's see other questions for the day. I think the ones I've gotten. Okay, this one says an atom has core, and outside the core, an electron occupies an orbital for which the principal quantum number n equal to L, m equal to 4, and s is equal to this. The atom is likely to be. Listen, this question, when I say live stream or live chat, I don't bring anything, but I'll still answer it as far as it's chemistry. Now, if they say the principal quantum number is 4, L is 0, M is 4, and then S is equal to plus 12 or minus 12. The question there is, let's check if you have 1, 2, 3, and 4. Okay. There is no, this thing is, you are making a mistake. This thing is not 12. Who call that's funny. Please, this spin is 1 over 2 or minus, is plus 1 over 2 or minus, not plus 12. Francis, are you listening to me? You don't copy this correctly, but I will answer you very well. You know, you represented the quantum numbers, the 4 quantum numbers, which are principal quantum number, the magnetic quantum number, the azimuthal quantum number, which is another name for. Okay, now let me go to our solving board and tackle this full time. You might come to our whiteboard. Okay, still live with me. Oh my god, I'm using so they said the principal quantum number n is 4, if I can recall. So let's, maybe I will have to divide the screen to help me. Yeah, the principal quantum number is 4. Then the azimuthal quantum number is 0. Then the magnetic quantum number is 4. And then the spin is plus half or minus half. Let's check whether what you are saying is actually correct. You know that L starts from n to n minus 1. Starts from n to n minus 1. So if n is 4, the possible values for L can now be 1, 2, and then 3. I guess so, yes. And when it is 1, we call it S. Then here is P, D. Let me understand your question very well. M is 4. How can magnetic be 4? Please, there is an error here. This thing cannot be 4. We don't have the... This is not 4, Francis. Take a look at what you are presenting. M, which we call ML, starts from minus L to plus L. That's from 0 to plus L. That is it. This is higher than U. I'm sure this should not be JAMB. But since you put it, you didn't even copy the correct thing. So it's not possible for you to have M as 4. M can either be 2. It can either be 2, 6, if I'm correct. Yes, 2, 6, 8. I mean 2, 6. No. It can be 1, 3, 5, and 7. Yes, that is it. Can be 1 and 7. So in that case, if it is 1, you draw 1 room, and that's for S. Then P, you draw 3 lobes. Then D, you draw 5 lobes. Then this one, you draw your 7 lobes. And each lobe contains 2 electrons, which spin up, spins down. So my dear, magnetic cannot be 4. The magnetic cannot be 4. I did not see the possibility of what we have, because if you talk about S, P, D, F, see how it works. This is 0, 1, 2, 3, and this is the orbital quantum number. So for you to know the number of orbitals that is in S subshell, what you have to do is you say minus L, because this is L, minus L to 0, then from 0 to plus L. So if you start for S, S will start from minus 0 to 0 to plus 0, which is 0. That is why we draw only one lobe in S. Then for P, you start from P is 1, L is 1 under P. You start from minus 1, you are counting up. After minus 1, you have 0. After 0, you have plus 1. So how many digits do we have? We have gotten 1, 2, 3 digits. So the number of orbitals in P is 3. That's why we draw 3 lobes. So there is no way you are going to get 4, my dear. So you go back. That question is incorrect. So now this one is D, which starts from L is 2 under D, which is minus 2, minus 1, 0, comma, plus 1, and then plus 2. So if you count this, you have 1, 2, 3, 4, 5, and that is D. That is why we divide D into 5. 1, 2, 3. 1, 2, 3, 4, 5. So there is no 4. I'm very sure of what I'm saying. So you go back and look at your questions very well. They are incorrect. And you have succeeded in wasting others' time. But no problem. No cause for alarm. You are trying to learn. So please, I still appreciate you guys for coming around in this live stream. The best thing you can do is just to endeavor to subscribe and share. You are live with SirMajesty. Check for other videos around here. You can also book for your own private classes anywhere you are. I will help you in biology and chemistry, in learning, and then also help us to spread the light. Okay, Dennis, thank you for coming over, but we are ending. So you guys, I say thank you, bye for now. See you when you come for the testimony, for the results. The exam shall favor you in Jesus' name. Amen. In whatever you believe in, if you're not a Christian.